Right.
And then all right. Welcome everybody. Our first presentation will be extending Survey 123 with JavaScript by Kray.
All right, thank you. Share my screen. So I am Kray Freestone. I'm a GIS developer at Northpoint Geographic Solutions, and I'm going to go over some examples of how to use the JavaScript files to extend Survey 123. The point today is less to teach about JavaScript and more to just teach about what JavaScript can enable you to do. So some of the code examples I might be flying through a little quickly, but I hope I can at least convey at a high level what is going on. So I'm just going to jump straight into Survey 123. I have a demo simple form up here. All that I did was create a new survey, went to advanced template, and created that. So this is just the standard form that you'll see in Survey 123. And 1 second while my computer thinks. And right here, I have the Excel format of this. So what I'm going to do is just change this and get this ready for my JavaScript. So I'm just going to have this be a enter your name. I'm going to put in a GeoPoint question, call it location. So for those who don't know, the name column is basically what the field name would be if you're in an ArcGIS Pro attribute table, and the label is what the alias would be. And I will just delete this out of the way. We'll see that reflected in the right-hand side. So what I want to do first is, for a really simple example, this is something that you could do straight through the calculation tab on the right-hand side over here. So I went to calculation. In Arcade, I could just concatenate a message. So if I did, I basically want something to say, when I enter my name in here, I want it to say, hello, Kray. So it's something you can do in Arcade, but for the sake of this, I'm going to go over to scripts, hit new script, and I am just going to call this hello.js, hit create, and right here it creates the function for me. From here, you can edit your JavaScript straight in this Survey 123 interface. If you have a code editor that you're more comfortable with, you can launch an external editor and it will launch whatever program file that you have associated with JavaScript files. So for me, I have that associated with, let's see here, I have it associated with VS Code. So I am just going to, it opened in a separate window. So we can see that same thing here, gives me a sample function. And so what I'm going to do is replace this with my own argument. So this is the first argument to the function, and I'm actually going to bring us back to Survey 123. So I want it to take this as an argument, and I want it to return a message with this argument. So what I'm going to do is copy over a calculation. I'm going to insert calculation type. This will allow me to access JavaScript. I'm just going to call it calc hello. I don't need a label for this. And for the calculation, in order to access JavaScript files, you need to use the pull data function. Specify that this is at JavaScript. So Survey123 knows what to do with it. I'm going to specify the name of my file. So I named it hello.js earlier. I'm going to specify the name of my function. And then I'm going to specify the argument, the first argument that I'm going to put in this function. So for this, that will be user name. So $, curly bracket, name of the variable username, and close that all up. And that will be the calculation. In order to see the calculation, I need to actually put that somewhere in here. So I'm just going to copy, paste that in there. Note that will have the output of the calculation here. So calc hello, that should be what spits out. Now it'll probably give me an error if it doesn't, because and actually it's not calculation, it is calculate. So now that I have that set up, I need to create a function called hello function, and that will be here. So right now it's called my function. I'm just going to change it to hello function. And this argument will be the first argument that I specified in my Excel form. So that is username. If I wanted to do multiple arguments, I could add in more stuff here. And each one of these would be subsequent arguments that you could put in your file. So now that I have an argument here, I only want this to process if I actually have an argument available. So I will let you know what that looks like. So I'm gonna have a message that returns that is plus argument. And then I'm going to return that message. And so that should return a message to my Survey123. So right now there's nothing, there's no argument in here, so it's not going to return anything. So if I do that, it should return that. It's a little weird that it just says hello when there is no argument in there. So if you want it to not process anything before something is available, you could put in if argument does not equal null, then do that. To put it more short, you could just do if argument, and then nothing should be processing. So the hello message isn't there until I enter something in, and then we have hello Dolly. A little bit of a silly example, because you don't really need JavaScript to do something that simple. It's a bit overly complicated. So say if you had an example where you wanted to do some more complex calculations, say the distance from one location to another, and you had to use a big function like the Haversine formula. Could you possibly do this in Arcade? I don't think you could, but even if you could, that would probably be really hard to write all of this out within one Excel cell. So this is where JavaScript makes things pretty nice. So the idea of this function is going to take some geolocation data and tell me the distance in kilometers from the Spam Museum in Minnesota. So let us set up, we have the back part of it set up, but we need to set up the interaction through here. So we have location, and I have to go in here and add some more calculates. So the Survey123 knows how to interact with the JavaScript file. So I'm going to add in a few extra calculates. And I believe that is all of, I actually need one more calculate. So location is being grabbed from here. I'm actually gonna put that up here. And I need to grab the X and the Y. Luckily, that's pretty easy. You can do pull data at geopoint. And then I can call the location. And then I can say what I want back, which is the X. Similarly, I can do the same thing for Y. I should name these calculations calc X and calc Y. And then I can call my JavaScript function, which I'll call calculate distance. And this will be another pull data at JavaScript. Same file name, different function name, which I named it Haversine. And I'm going to put in my 2 arguments. So I may have mixed up X, Y, lat, long, because I can never keep those 2 straight. And I am just going to put that in there. So I got my 2 arguments in there. And then I need to make sure this information is put out here. So I'm going to make another note, call it distance, and the label will just be calc distance. And hopefully it should then take my location data wherever I go and tell me how far I am from the spam museum. Now you might get some cryptic errors during these times. So that's why you have, let's see, calc X. That's why you have backup forms. So same idea, still enter my name. I can also pick a location. So I believe it'll put me near Redlands, California. And it'll tell me how many kilometers I am from the world famous spam museum. I could go to Austin, Minnesota. And I believe that will be pretty close. Yep, less than a kilometer from there. So that's a way you can implement a distance formula. For something a bit more interesting, we could try and see what the weather is at any given location through the Open Weather API. So I'm going to close out of that, open up this form. And to set up the front of this. So I'm going to quick copy paste this information in here. Yes, yes, yes. So let's see if it likes what I just copy paste in there. It might not because I don't have JavaScript set up in there yet. Missing calculation. My apologies. I assume whichever form I started this in might have slightly separate order of columns, which it does. All right, so I have my location set up. I have a spot for the weather, temperature, real feel, and wind speed. So to break this down, I'm calculating the X and Y again. I'm just pulling that from the GeoPoint. I'm putting that X and Y information into my weather.js file, which I need to create, my weather function, which I also need to write out. And then I'm pulling the information from what is returned from that function. So I'm going to go into my scripts, create a new script called weather.js. I will launch this again in my VS Code so it looks nicer. And I have my function again, which I was going to name weather. And it takes two different arguments, the X and Y. And so to make a web request, you kind of have to do it. You can't use any external libraries like jQuery to sort of make things easier. You have to do it in vanilla JavaScript. So in order to do that, I'm going to create a variable. Let that be an XML HTTP request. I have to establish the URL that I want to get, which is from the open weather map. Oh, I forgot to mention, I also take different example. And then I need to open that URL, get, and then I'm going to finally send it. It's a little verbose. To get the response. Then I'm going to return all of that information. So you'll also notice I'm inputting that X and Y. I'm also looking for an API key. I got my API key here. I'm going to delete it after this talk. Please don't abuse this API key. It's just a free account. So this should be everything that I want to get from Open Weather API. So now I can go back into Survey123 and first need to get my location. See what it's like in Redlands. Of course, it's just beautiful because it's California. So that's what it is there. In order to see what's kind of going on behind the scenes, I could change this text. So all of the data is being stored into a variable called myJSON. So everything that I am trying to extract is all in this response that I got from this website. So from that JSON, it might be a little hard to see just because I'm quite zoomed out. So I'll try to zoom in some more. I have there's weather description, the main temperature, the main feels like, and wind speed. I believe if I just show the text, it should show what the JSON actually looks like. And it's telling me right now it has nothing to geocode because I did not give them any information. See what it's like at the Spain Museum. So it spits back all of this information in a big object that I can then parse out. So you can see main temp is equal to main temp. That's how I'm getting all of that information there. So yeah, and on to the third example, because I see I have about 6 minutes. I'm just going to go straight into my working example, and I will show what is going on in the code behind it. And let's see here. So basically what I have here is a place to put the inspected date. The scenario here is that somebody's inspecting some wells. They want to get the gallons per minute in there. These numbers are likely not realistic, but I put in some random values. And the idea is that they want to record a value at a well, and they want to know what the average reading is at that station, but they also want to know what the most recent value is at that station, so that when they enter some value in, if the difference is really high, it might alert them to an error on their end, something wrong with that location. And all of this information is coming from ArcGIS Online. So I will just jump straight into the JavaScript, but to kind of show, I'm calling the JavaScript a few times. The first is to get some the global IDs of these features that are in ArcGIS Online. I'm grabbing the token of my username. You can grab unique tokens, like when you need to access certain items in ArcGIS Online and it asks for a token. You can generate those here, so you can validate requests from ArcGIS or from Survey123, so you don't have to like hard code in passwords or usernames. It will just take in that data right from where you're logging in here. And then I'm just extracting the JSON that gets returned. So I already have my script going, so I'm just going to pull that up. And so this is the, you would want to do this in a different way, live version, but this is just for a sample. Each one of these is returning a global ID. And then when I have that global ID and that token, I'm just making a GET request for that API, for the ArcGIS REST API. So I want all of the fields where parent global ID equals the parent ID, token equals token. And then to get the most recent record, I'm seeing whichever one is basically has the greatest value in the inspected date, which is the date field. And then for all the gallons per minute, I'm just grabbing all of them. I'm calculating the average of all of those. And then I'm putting those two values in. What's the most recent value? What's the average value? And then it returns all back. To show a sort of more realistic implementation of what this would probably look like, I have a small GIF ready for this. So I forgot to switch over to the Spam Museum. It looks glorious. So this would be opening up field maps. Going to the first part of this just kind of explores that each one of these wells has a related table of inspections. So we can see a few of the readings from the wells. I'm examining a few more. And eventually I'll click that inspect hyperlink, which takes me to Survey123. It'll automatically fill in the well ID, and it will pull through all of those previous readings. So it will do all those calculations for me. So I don't, another workaround for this would be to use the pull data function to pull from a CSV of previous values to do calculations like that. The only problem with that is that you have to calculate that data and you have to re-upload Survey123 form in order to get all that information. So this is live, but speaking of live, that kind of has a few drawbacks. I will sadly not get to Webpack unless there are no questions in the Q&A and people want to learn about Webpack, because it's another even more powerful way to use JavaScript in Survey123. Limitations are this doesn't work in public surveys. I don't think Esri has a plan to make them work in public surveys because I think it's a security risk. They only work within the same organization. So no cross-organization JavaScript, Survey123 stuff. Can't access local files, so you can't read in a GeoJSON file or a CSV that your JavaScript file relies on. Can't use JavaScript frameworks like jQuery or React or anything like that. You are solely reliable on vanilla JavaScript. And this last one might not mean anything to you. If it doesn't, it probably doesn't affect you, but you can't make asynchronous calls to the internet. So yes, again, Kray Freestone, JS developer at North Point Geographic Solutions. And if anybody has questions, I can take questions, or I can go over some of the Webpack stuff, which is pretty neat and powerful. But I'll put this, this is the URL to the presentation in case anybody wants to look at it at a later time. Oh yeah, I can show the calculate distance in this spreadsheet, of course. Let's see here. Simple. So the calc distance takes in at JavaScript, hello.js, the name of the function, and then the X and the Y. And the back part of it looks like this. It's a lot of complicated math stuff that I copied from Stack Overflow. So any other questions? Yes, I am also disappointed it can't be used in public facing surveys because it seems like it'd be very useful. All right, well, got 3 minutes. I can just go over, Esri released a way to use third-party libraries in JavaScript, so you're not just stuck to vanilla JavaScript, which I did say was a limitation, but Esri actually enabled a way that you can work with libraries like Turf.js or Proj4. So you can do more complicated functions. So for example, for somebody, I set up a Survey123 form so that they could take the location information of where they're at and to see what county they're in. So I could load in a JSON file of all the counties in, say, the state of Minnesota. And then depending on where their inspection was completed, they could enter their information and it could do an intersection test with what polygon is this point inside of, which is something you might be able to do through the ArcGIS REST API, but you could not do locally. So the cool thing about this was it could do all of those calculations locally. So even if you didn't have access to the internet, you could still do intensive geometry calculations without needing the access to the internet, which is nice. That's also another thing to mention. As long as your JavaScript functions don't rely on any GET or POST requests to anywhere online, whether it's a weather API or whether it's ArcGIS Online, it will still work offline. And I believe that's all the time I have.
Thank you, Kray. Our next presentation will be Privacy by Cory.
Hey everybody. We'll get sharing here. So first thing, I'm going to put in a request that we're allowed to use emojis in our conference abstracts and titles when we put them in. Anybody that's ever worked, when I babysit my nieces and nephews, and there's so many times I've heard this from them, they're just like, oh, can I please get some privacy? And it's one of those things where with the amount of data that's out there about all of us, it's really hard sometimes to feel like you're actually getting privacy. For those of us that were born in the late 1900s, as my niece would say, the late 1900s, this is the worst you had to worry about, is a few of your Polaroids or family photos getting spread out on Facebook, or someone getting copies or something like that. Nowadays, everything is out there, it's everywhere. So folks have heard me talk about this before in the past, where we know that our phones are tattling on us all the time. I mean, we're walking around with these little GPS receivers in our pockets, and so many people forget to turn off location services, or they're intentionally using them. And this has been kind of an interesting dive. So with a little bit of background for those of you that haven't heard me talk about privacy and data before, I've done work part-time as a crime analyst in our municipality. And this is actually one of the biggest things that I'm always looking for, is the data that folks these data tracks that people leave out, that they leave everywhere. So I have since become a very big advocate of privacy and data privacy, because I've just seen how much people leave around. Now, some of these things that you're going to see cited here in this presentation, these go back several years. I mean, this is not a new subject by any means. Some of this goes back quite a ways, even more than a decade. But when we look at this point here, talking about this particular research study, and how many times a day people's location was getting reported just based on the apps that they had downloaded. I mean, could you imagine if you found out that your location was shared more than 4,000 times in the same day, or in the same 2-week period? I mean, could you imagine if you're seeing your GPS location getting shared thousands of times over the course of a few days? So what was interesting is these researchers, they had an app that was remind people about their privacy, and it would nudge them to say, hey, did you know that your location's been shared this much? And they found that the majority of people actually, when they got the privacy nudge, that they were kind of changing the attitudes of folks and their kind of default position of set and forget. So folks are going in and actually actively looking through their apps and changing the privacy settings. Now, one of the issues that they did note with this is a lot of people, because you had to go in one by one. It would have been different if people had been able to go in and kind of bulk edit everything, but because they had to go in one by one, it made it a little harder, and that opt-out activity slowed and would stop until the next nudge came. So this is just a clip from Snap Maps. So anybody that uses Snapchat, this is just an open map that you can go and you can check out who is putting Snapchats up. I was careful. This is why I don't do live demos with this, because I wanted to make sure that the snaps I selected were appropriate for what we were talking about today. And that is the warning I will give anybody that does live demos with social media. Know what you're clicking on before you start putting that up on a screen. But this is exactly the sort of thing that people just don't even realize that this is out there and being publicly shared all the time. And it's just out there for consumption. Now, it might change some habits of some of these people if they knew that some GIS person was going into Snap Maps and clicking through all of their stories and all of the snaps that they have sent. And if at any time, please, use the chat, use the Q&A. Please put your questions, comments, and that out here, because this, even though we're not in person in like real space, I do like the dialogue with the audience and what people have questions about or comments about as we talk about privacy, data privacy. There have been some updates recently between Apple and Android, iOS and Android, that it's changed a little bit of how some of the location services are being collected. It used to be pretty bad, like even just a couple versions ago of iOS. They had a function at one time, and with the latest version of iOS, I haven't dug through deep enough to find it yet, so I'm wondering if it's still there or if they finally disabled it. But there was basically a log of all of your frequent locations, and it would give everything from the average amount of time that you spent there to how many times a week, and you could just harvest an immense amount of data based off of just your GPS tracks with iOS. There's some examples there on the screen of, phone tracks and different things, and I'm sure a few people recognize the Find My Friends icon there. So I do share my location with other people on my work phone. That is something that I intentionally do. And I'm sure a lot of people are a little bit shocked by this, that I actually intentionally will share my location with a phone. But it is not, it's a work phone. If they wanted to at any point in time, they could track me down. So there's some stuff that I myself have even kind of resigned myself to the fact that, hey, people are going to have my location. This is how it's going to go. Now, that work phone doesn't travel with me everywhere. Like, I try not to take it on vacation with me or other places like that, but I do have it on me. So just pulling some headlines, and these aren't even all like current headlines. So an interesting thing as we keep talking about data privacy is we talk about, we want people to have private data. We want people to have data privacy, but then kind of right there at the, at the top there, where it says that the census, how many of us count on having good, accurate data to go with the census, this location data, but yet we still want privacy. And it's been a discussion that's been ongoing for quite some time and still continues even about the 2020 census, about how them doing the work to maintain data privacy has actually caused some issues with accuracy. I haven't heard all of the solutions. If anybody knows of any of the final resolutions that they've come to on some of these, please share with the rest of us, throw links up in the chat or something like that to let us know. But I think that's still going to be an issue that they're going to have going forward, the 2020 census data. Is one of the things that they do guarantee, I believe it is, your data is guaranteed to be private for 70 years from the time it was collected. So that's, they eventually release it so it can be found by, like ancestry.com and those other genealogy websites and researchers. But it is I believe it's 70 years is how long they have to keep it private. So one thing I found very interesting here too was the research that was done to say that folks could be found, they could identify 90% of people based on credit card transaction information. That's probably going to start using cash a little bit more. So with this here, kind of getting into more of the background of data privacy, demographic attributes. So if you notice there at the top point, they use 15 demographic attributes to identify more than 99% of the folks. But then in the next one, 4 spatial temporal points. So 4 location points, and they were able to get a 95% accuracy. So that is really interesting to me, because that's one of the things that I'm always looking at is our location data happens to be some of the most unique and telling data that we have, that we're creating every day as we exist in this world. It's even more unique than our social security numbers, our birth dates, any of these things these characteristics that we have about us, our location data tells the world so much more about us than those other demographic attributes. I mean, there are other people named Cory. There are other female identifying people named Cory. There are other people that live and work near the city of Blaine. Like, there are definitely characteristics that I have that I share with other people. But then when it comes down to something like my location, especially that spatial temporal location information, then you can start to narrow it down. Like, who am I? Where do I live? Where do I work? Where do I go to worship? And those sorts of things. I went into check out this tool that is one that came out of one of these studies, and it's called Too Unique to Hide. And it's a little bit of a grade to figure out, like, how unique are you based on these data points that you give them. So again, yes, I understand, the irony of the person talking about privacy, and here I am punching in information on a website. But I punched it in because honestly, what they were asking for, that's all information that's already out there. That's already information that's been well published in a lot of different places. It's something that's not hard to find between my birth date, my gender, my zip code. And oddly, I only came up as identifiable 66% of the time. So that's better than most. So that means I'm doing a pretty good job on cleaning up my digital data tracks, but I could do better. That's one thing it does tell me. So folks may not know this. And I don't know if anybody has, and maybe like raise your hand or put an emoji in the chat or something. Has anyone heard of the right to be forgotten, or the right to erasure, or the right to privacy, like in that sense? So I'll just give it a few seconds to see if anyone can say yes, they've heard of it. One person's heard of it. Panelist has heard of it. Perfect. So at least a couple people have heard of this right to erasure, this right to disappear, the right to be deleted. And we haven't quite caught up here in the US. They do have this GDPR over in the EU, and that covers basically the sorts of things that I feel like we really should have here in the US, but we don't have a singular law federally that really covers privacy to all types of data. We do have a whole mix of laws out there. People have heard a lot about HIPAA. I mean, there's no doubt that we've all heard a lot about HIPAA these past few years. But there are other laws that, and it's kind of like this weird little mishmash of things that are out there between the federal level and the state level. So in most states and in Minnesota, companies are able to share, sell, use the data however they want about you without notifying you. There's no standardized law about notifying you if your data has been breached by an unauthorized party. There is nothing really to say that any of these companies, that if they share sensitive information about you, that they have to notify you. A lot of this really kind of is out there in this wild, wild west area where it's just out. I mean, we've heard about many of the large data breaches that have hit the news and the sensationalism behind them, but we're not hearing about the stuff that's happening day in and day out, which is a little scary once you really start digging into it. So with the mishmash of laws, like, there's some stuff about educational rights, there's some stuff about fair credit reporting, there's a handful of things that they've been trying to put, communications privacy and other things on there. But again, we still don't have this GDPR, this idea of a right to erasure. So you can opt out of having your data shared, that you can really, you have the ability to tell people like, don't share my information. And so when we look at consumer protection, there's only 3 states, and you'll notice that we're not on that. There's only 3 states that actually have comprehensive consumer protections. And then, of course, here looking at a state-by-state look at privacy, you know, this is what it looks like at the moment. Minnesota does have some stuff in committee, but it's hard to say, you know, are we at a point within the state where we're going to see, does the freedom of speech, which it has in some Supreme Court cases, does the freedom of speech trump the right to privacy, the right to having your data not shared? So going over a little bit more of the no variation, the no national laws. With all the variations that are out there, it's no wonder that your average consumer isn't able to navigate what's happening, right? If you have 54 variations of laws that say what your rights are when there's a data breach, like how is the average person supposed to figure that out and to follow that? And one of the thing that folks have been agreeing upon that are here for data privacy and consumer protection is that these 4 areas are key to making sure that we have basic protections for our consumers and for our people. You know, that there's regulation about the data sharing and collection, that there's opt-in consent, that there's not an assumed consent, and they don't also use an opt-out model, which is the majority of companies, and they actually use an opt-out consent model. So you have to go in and opt out of it. They don't tell you that, hey, we want you to opt in. They're just going with, because you use their product, you automatically opt in until you go in to tell us you opt out. Data minimization, so making sure that they're not collecting more data than they actually need to conduct business with you or to keep information about you. And then the non-discrimination for no data use. That basically means if we had a comprehensive law that said you could turn off the cookie tracking on your web browser, that would mean that you wouldn't get penalized for turning that off. I mean, we've all seen the warnings, like if you turn off cookie tracking, the following functions aren't going to work, or your website might not work properly. I do realize that there's transactional reasons to have them, but this is overall when we're talking about the collection of consumer data and privacy. And, you know, bottom line, I mean, it's hard to achieve because there's so much money out there in selling our information. So getting down to the whole question here, we're geospatial people. We handle a lot of geospatial data and location information, and there's people that are behind all those data points in some fashion. So what is our ethical obligation? I really like this quote that I grabbed from Professor Nagel, and this is in regards to talking about the census and the census data anonymization. So what the point was here is that making sure that we have accurate information in order to do our best with decision making, but how do we balance that with privacy? And I think that's a very hard question at times. It's like, if you have to anonymize things, that you could actually skew what you're getting for accuracy with your location information. Is that worth the privacy that you're giving to others? Now, a whole bunch more headlines. Talking about our location data, and again, this goes back to what I was saying earlier, is location data is some of the most telling information that we as people create, that we as living creatures create. We can get so much out of this. And I've seen it firsthand, just working cases and that. But when I look at the difference between can't track and won't track, that's a major difference between those two methodologies. And you know, this particular headline that I grabbed, it's more than 7 years old. So this actually was like a 12-year-old article or something that I grabbed this headline from. And it was just like, you know, this is not new. This is not a new concept. This isn't something new that we're running up against. But we're still debating it. We're still in this situation where we don't have comprehensive consumer protections, and we don't have comprehensive data privacy. So what does that really mean to people when I talk about data privacy? It's this. You know, we want to make sure that unauthorized people aren't getting to our information, right? And I think us as professionals, as students, as colleagues, all of us can agree that we don't want to be the person that's responsible for a major data breach or a major data dump that exposes a whole bunch of private information about individuals. None of us wants to be that person. None of us wants to also be the person that has had all of their information exposed. So what actions are we taking on a regular basis to know that when we're handling the information that people trust us with and that we're getting, what are we doing to make sure that there isn't this unauthorized access? Inappropriate use of data, it's the same thing. Like, we want to make sure that people aren't exploiting the information that we can provide about an area or a population or any of these things for negative purposes. You know, we want to make sure that people know that the information that's being collected and shared about them is accurate. The number of folks that have had to battle with inaccurate information or even information that gets wrongly attributed to them, because maybe it is a thing, like they share the same name, the same location, gender, or other characteristics that somehow they ended up getting tagged with all of this data baggage that wasn't theirs, but it was just because they shared similar characteristics of where that should have actually gone to. That right to access, you know, that the person that this data is, so every time that I create a location point, as I use my phone, as I move around and everything else, that's actually my data. Like, I own that. But I've got people that are taking it all the time without asking for permission or for consent to take that. And then the ability to actually go in and correct and update data. I think that's a big, big thing a lot of us work with on a regular basis if we're working in municipal government, is the number of times that we have to go in and it's like, oh, that street's wrong, or the address is wrong, or, you know, I have to update the spelling on this particular attribute or this particular asset. We're always dealing with the idea that we get to go in and correct data, but do we give that same opportunity to the people that are collecting data about? So with location, there are some things about location data that's legally sensitive. Even when we try to do stuff to anonymize information, it's difficult. There's a lot of things that make it difficult, because when you look at aggregated location data, and this is where they've had issues of secret military bases being discovered, because all of the soldiers that were there were using a fitness app, and this fitness app was registering like all of these people moving around in this one particular area, and pretty soon it was no longer a secret military base. There's things that are telling on us all the time, and again, we don't have that opt out, right? We know that a person's patterns really is what makes them identifiable like a pattern is what makes it difficult to anonymize. Aside from the fact that, back to the 2020 census, the issues that are introduced with the fact that they're trying to anonymize certain sets of data, and they found that it very negatively impacted small populations because it's hard to anonymize when you have a very small sample set that you're working with. So as I'm kind of winding down the last couple of minutes here, I'm interested in your thoughts about our role in what data privacy is, and our role, our ethics of protecting data, anonymizing data. And are there things that we should be thinking about at a bigger level here? Is this the call to action for us to all get together and to push for these consumer protection data acts that are currently in committee? Is this a good time for us to reach out to folks to make sure that things like location data, there are protections put in place for people, but at the same point in time, it doesn't ruin the integrity of the data for analysis? So that's the question here. And because I can break the rules, because right now I'm a co-host until Annika takes me off of being a co-host, I will unmute people. So if you raise your hand and you want to share something, please do so. Does anybody want to share how they view their role? How ethics affect it? Well, I'll invite my host and my fellow panelists to unmute for the last couple minutes. If either of you have questions, comments.
Yeah, I think the stuff you brought up about the census is very interesting, because I've seen a lot of stuff too about, is it necessarily inaccurate or unnecessarily inaccurate this year? Seems pretty split. The census seems to say nope, this is how it should be. And a lot of researchers saying it's unnecessarily inaccurate, and it's not necessarily more safe. So I don't know, I agree, it'll be interesting to see how things shake out.
It will be. Yeah, I know that they've been doing some adjustments to the algorithms, and they've continued to change some things. And I don't know, I know other states that we have seen some census data come out and some preliminary information. This is kind of like our biggest example with the census of people's location data and how that would be affected by data privacy or how we aggregate and anonymize. But I mean, every day that there's stuff being created, and as we roll into my next talk, talking about traffic information and that sort of stuff, there's examples all the time of how we collect information. And at a municipal level, we collect a lot of information about people without really anybody having a second thought. The amount of information that we'll get about a person when they apply for a permit, a license, even reserving a picnic shelter, we're keeping a lot of this data, and I don't know that always there's a lot of thoughtfulness given to how we protect and anonymize, or do we even need that, right? So what is the collection level that we actually need for some of these things?
Yeah, that's a good point about local government, because I once scraped a bunch of information from a local government. I was interested in see where code compliance cases were locally, and looking back, I'm like, well, should I? I mean, it's all available, but should I have scraped it and made that easy to view? I don't know.
Yeah, and I think that's the question we all face. So, all right, well, now that I've scared the bejesus out of people, Oh, I do see. Okay, so there's one thing in the chat. To do what my boss tells me to do, the ethical gray area. So following orders. That is a tough one sometimes. You know, when you are following orders from up above, yeah, that is an ethical gray area. I don't have a good answer for that, especially since I'm in a supervisor role, and I know that there's sometimes I feel like I'm giving orders or asking for projects or things that may kind of fall in this weird line. So, all right, well, that's my time for that. I'm going to stop the screen share, give everybody a moment to shake off the data privacy talk as we start to talk about traffic. Let's look at my other presentation going. All right. So 231, we will be discussing. So hi, everybody. My name is Cory Richter with the city of Blaine. And I will be talking today about what a trip, looking at trip data. And the question of how do we use this when looking at street design and other questions about kind of the design and maintenance of roadways within municipalities. So first things first, there's probably going to be a lot of traffic puns during this presentation. I apologize. I guess this is the point where we're going to go with it's a good thing people can't unmute because I can't get crowd heckling. So from there, so I did end up taking a little detour with this presentation from the time that I submitted the abstract. And anybody that submitted an abstract knows the pain of this, that you have a project, you have an abstract, you have a great title, you have all these things. And then as you continue to kind of tweak and develop and go, sometimes stuff kind of takes a little bit of a turn on you and in ways that you may not have anticipated originally. So I promise there's still going to be some good content. You can throw virtual tomatoes at me if you don't like it. But anyway, yeah. So what is the role here of geomatics and GIS with traffic and roadway efforts and design and maintenance? That question that I asked in the abstract saying, you know, should we be considering daily trip data and designing and maintaining infrastructure? Well, the answer has been and still is yes. We just had different ways of collecting it. You know, we have, they always do design studies, and just as they're going with different design configurations for intersections and traffic calming and everything else, they'll do all of these different studies where they go out, they take trip counters out there, they'll have observations. There's a lot of stuff that's gathered constantly when they're looking at how to design and maintain roadways. What started this idea and kind of getting me down this path of looking at roadways and how all this keys together, and what geospatial data that I have to offer, as well as, you know, is it something that's useful to our engineers? Is something that could maybe influence some future things or not? Well, it does. Just the way I thought I was going to go about it ended up a little different. So a little background in the city of Blaine, a big suburban community, actually number 10 in the state now with the latest census information. We hit over 70,000 people, but we really, we're kind of in the outer ring suburbs, and the type of traffic that we get, because we have limited public transportation systems and we don't have a really big network of bikeways and pedestrian walkways and stuff for people to move about the city. And we don't even have like a city center, so to speak, like we do with other large areas. So it's designed very much for car traffic. And we have all these little neighborhoods and pockets of development all over the place where with dead end roads, cul-de-sac circles, and kind of all these little complicated road networks instead of this really pretty grid that we see in some cities and some designs. So some of what I was hoping to find and use didn't actually end up being super, super useful, right? So limited transportation network. So looking at bus information and bus data and travel and traffic and that. And of course we had a year where all of our road systems and travel and everything else were completely upended. And we have not returned to pre-2020 levels of traffic in some areas. It has increased quite a bit. And I'm sure anybody that has to sit through rush hour traffic would disagree with me that we haven't returned quite to the same levels, but we have not returned quite to that same level of people using cars Monday through Friday the way they used to. So a little bit of background data talking about roads. So I'm sure everybody knows this, so I can kind of speed through this a little bit. Arterial roads, basically we're talking about those big high capacity roads. And this is not like the interstate system. So interstate is one level above arterial road here. But these are going to be our big high capacity roads. This is where we expect the majority of our traffic to funnel. Our collector roads, these are kind of those are kind of our feeder network here, where we're taking that traffic from our neighborhoods and we're pushing them out to those arterials. So we can take them from the much lower speed roads and we can push them onto a higher speed road, hopefully getting them to their destination faster, safer. There's a lot of debate around safeness and that, but that's the idea, right? So we have these collectors that take neighborhood traffic, put it out to our arterials. And then our local roads. So these are our low capacity roads, residential properties, it's lower speed limits. This is where you're going to find a lot of those kind of traffic calming things. And you may even have uncontrolled intersections, yield signs, stop signs, versus, you're not going to have lighted intersections or that. That's going to be something that would maybe be a local road coming up to a collector and then from a collector to an arterial. But generally, this is the sort of thing. So at the top here, this is what we would in Blaine look at as like an ideal situation for our local roads, for our streets, where there's nobody parked on it. We really don't see any traffic on it, versus down below where that's a clip, I think, from like San Francisco or somewhere. And you've just got cars parked and traffic and all sorts of stuff. And that's the sort of thing that people don't want. So neighborhood traffic's always going to be an issue. And I think depending on the type of municipality that you work in or the type of company you work for or whatnot, you're going to run into different levels of complaints from residents based on kind of the neighborhood construct. So where we are up in Blaine, I mean, people have an expectation of, they don't want people parking on the street. They want people parking in the driveways and the garages, and they like to not have, a bunch of people driving up and down the road in front of their house. It's actually a big complaint that we get a lot, is there's too many people driving through my neighborhood. And what that comes from is from this, right? This comes from all of our apps, all the different ways that we ask and do our trip data. Because as far as these are all concerned, what they're trying to do is to get us to our destination fast enough, or fastest and safest, I'll use quotes on that. But the idea is we're either taking the shortest distance or the fastest distance. So It's just straight up an algorithm that looks at it. And I know that there has been work on the side of Waze and others to incorporate information about like truck routes and like restricted residential streets and some of those other things to help discourage some of this excess traffic that we see coming around into different neighborhoods. So raise your hand, use the chat. I'm interested in hearing people's stories about what you've heard. What have you heard from others when they have complaints about there's too many cars on my street, too many delivery trucks? So hopefully a few people will chime in here. So the most common thing that I hear is it usually comes down to me from a council member or from the city manager and they usually are contacting me to say, hey, can you tell Google to no longer send trucks down this street? And my answer is pretty much always the same. It's like, well, no, I can't. But let's talk about what this issue is. What is this issue that we're having here? And is it Google? Or is it the fact that you've got 5 people living on that street that order from Amazon every day? Like what is happening that we're getting so much extra traffic there? And sometimes it's just a matter of people have found a really nifty detour to go through a neighborhood, and then that habitually they just keep taking that detour. So I don't know if anybody has a story they'd like to share. So here's a good one. A street coordinated. Okay, so you're street coordinated together to get one garbage and recycling truck company rather than having multiple contracts. So you only have 2 trucks a week going down your street. That's actually pretty good coordination. I wish more people would do that. In fact, I live in a cul-de-sac with like 12 houses, and we have 3 different garbage and recycling carriers. Cul-de-sac of 7. Well, there's hope. There's hope that I can get that. We can get that coordinated. So when talking about traffic, it's really non-linear, right? So even though we like to think that if we double the number of cars, that means we're going to double the amount of time. If we have the number of cars on the road, we're going to have the time. This is what I get for talking for an hour, and I have allergies. So because it's not linear like that, right? We can't say like if we have twice the traffic, we have twice the cars with twice the traffic, twice the backups. It's because not everybody's using the same segment of street at the same time in the same way. I know we've all heard of what a bottleneck is. We know what a traffic jam is. Does anybody know what a spill box is? Put a frowny face in if you don't know what the spill box is. All right, I got 1 frowny face, 2 frowny faces, 3. Perfect. I love it. So basically what the spill box is that would be like your collectors, and that would be the point at which your traffic is kind of spilling out into the network. So that's going to be a point where you're going to have the likelihood of backups and jams is at that spill box point, where you have a whole bunch of traffic kind of coming into this one area to spill out onto the rest of the network. So hopefully that makes a little more sense of what the spill box is. Lane drops. We've all seen that. Lane ends 1,000 feet ahead. Shockwave. Same question. Do folks know what a shockwave is? Frowny face if you don't. Gotta know. So a shockwave is when I like that shockwave is the clown of traffic. A shockwave is when you have that unexplained stop in traffic, and you're going along, all of a sudden the traffic like stops ahead of you, and then you get to the point where you're thinking like, I'm going to see a tow truck or an accident or somebody pulled over, and there's nothing. Like there's no reason that there was this stop that occurred in traffic. That's what they call a shockwave. And usually what creates a shockwave is somebody for some reason taps a brake and it just kind of rolls backward through traffic. So someone taps their brake real quick, maybe they like, I don't know, drop their phone. They shouldn't have been on their phone anyway, but we know that people use their phone all the time when they drive. They may have seen something like run across the road, whatever, but that's the shockwave, that first brake tap, and then it just goes back through traffic. So those are those unexplained stopping points that you'll see happen across traffic. Now they've tried to different with the DOT and other municipalities and levels of government have tried to teach us better driving habits to reduce things like the shockwave and that. With, we've all heard about the zipper merge, we've seen the campaigns, and the thing about those is it works in some situations, but it doesn't actually work in all situations. The zipper merge really only works when you have like low speed traffic, versus if you have high speed traffic and people are trying to merge at the last minute, that's when you'll create those other behaviors like that shockwave, because somebody will tap their brakes because suddenly somebody merged in front of them. Versus if it was a slow zipper merge, those can run pretty smoothly. Aggressive driving is basically what disrupts our traffic most of the time, because those are the people that are following too closely, so that when someone does tap their brakes in front of them, that person now has to slam on their brakes so they don't hit the person in front of them. And then again, you see that kind of pattern back through the rest of traffic. So if anything, I just gave you some good trivia for Thanksgiving and the holidays. So actually talking about trip data. Okay. So I'm going to cover a few of the very readily available sources to a lot of people, looking at information like Waze. Now, I shouldn't say it's readily available to a lot of people. So Waze just recently rolled out their new partner hub. And if you are part of a municipality, you can become a partner with Waze. So you can get information as well as report like construction and that to it. And I'll totally give major props and shout out to Matt Richter, because he was the one that told me about the interaction with Waze, and that's how I kind of got involved with that. So they do provide some feeds, but what I found a little more interesting is being able to use the reporting tools and actually getting these different lists out of them. So getting traffic alerts and like what those types of alerts were, those things that were reported. And this is where some of my work kind of took a little bit of this turn, like I said, this detour and what I was looking at. So I started looking at these alerts. So the traffic alert feed, and then these accidents. And pretty soon it's like, okay, this isn't quite matching up with some of the accident data that we have from the police department. So I've been looking a little bit more at, are these points that are getting reported for accidents, how do these actually match up with the CAD data that I have for traffic accidents? Are we seeing a large number of unreported minor accidents? Or am I getting like bad lat long data from either the Waze report or from the CAD report? And the answer to that is yes, there are a lot of minor accidents that go unreported. And the other part is the data that is reported here from this feed to tell me about the accidents, it actually wasn't too bad when I could get kind of times and dates to match up. It wasn't too bad as far as location. So this actually gave a little validation to some of the CAD data that I have been working with over the past couple of years. And then these traffic irregularities here that are reported. So I haven't fully found a use for the irregularities part here, but the accident one has been interesting. And then even just using back to the feed here, right? What I get on the feed though is mostly just limited to arterials and collectors. There's just a little bit of information that will pop out onto the local road system. So not something terribly usable when I'm trying to look at things like how we do detours and are people using them, or are they finding their own detours? And if anybody has questions, please pop those into the chat or the Q&A. And then we've all seen the Google Maps live traffic. You know, again, this is kind of the same thing, right? You're limited to those arterials and those collectors. You may get a little bit kind of off here and there, but it's just, you know, it doesn't tell me anything different than what I already know based off of the average daily trips and, you know, the traffic counters that are out there, the ones that the state does and that we do locally. Same thing with Esri live traffic, right? So there's two layers if you haven't explored it in ArcGIS Online. There's a live traffic and then there's a historic traffic. Now, historic traffic, I found that a little interesting because of how it was showing traffic within my neighborhoods too. So it's kind of, I've been poking around into that, trying to get a little bit more information on what exactly it is that I'm looking at here. Because there are a few things that I found kind of interesting as I looked back of, well, hey, you know, when we set up some different detours, you know, does that mean that people were following them or were they not following them? So one area that I especially was interested in is right here, is in this area here. There's a street right here that I know with stop signs and other things along this route, I know that sometimes that folks will actually detour out of the main road because of the number of times that they hit a stop sign. And they'll go kind of around other ways to get through different neighborhoods. So instead of coming across, so instead of going and doing the full run this way from across a big arterial to get over to a collector, you know, sometimes people will go this way instead. They'll head down this route and then out. So this gave me a little validation to things that we've seen in real life and some things that we've had observation from officers and from neighborhoods and that. So it was nice to see it, but again, like I need a little more information on what's happening here. But I was a lot more interested and a little more distracted by this accident data because it's been something I've been working with quite a bit as we talk about road safety. Something, of course, you know, and you can also get this off of MnDOT on their viewer. So we've got central, you know, so Highway 65 and then I-35. And I just want to point out the number of vehicles traveling between these two roadways. And everybody that travels on Highway 65, they know the issues of, because we have multiple stoplights along there and those issues that happen at those different stoplights. And it leads to kind of some differing traffic patterns of how people end up pushing out to kind of our side roads, to our frontage roads to get around what's on 65. But I mean, we've got more, I mean, granted, these are 2 different years that these traffic counts were taken, but just, man, we got 51,000 vehicles on a traffic count there, and 47,000 on a traffic count there. So you can see that this 4-lane highway is as much traffic as an interstate. So hopefully we get funding to get some of those grade separations done there. So OpenStreetMap and using the public GPS data trace. This is kind of where it gets a little more fun and nerdy for me, is digging into some of the OpenStreetMap stuff. Now, granted, I just put the key here so you can see. It's not like purple means that that's awful traffic or anything like that. It's just mostly about direction. Now, one thing about these public GPS traces is you'll see that, so like this area, so right here along Clubless Parkway, there was some construction and there were actually lane closures. So there's actually no tracking here, which I find it kind of funny. Like I've got a track that kind of comes along back on this walking path and then picks up here. So this is kind of like a pedestrian way here, but just seeing like how that went. And then this is that GPS jump that some of us have seen, unless this person actually just like ran across that way. But this public trace, again, it's not something that you can always say it's going to be somebody that's on a roadway, right? It's going to probably be folks that are walking, biking, or other things. And some of that you may be able to determine based on, you know, if it looks erratic, kind of how they're going around. And then so here, and so this was the part here that I was talking about, some of that kind of erratic GPS trace that we had through here. So this indicates to me this is probably somebody on a bike or something like that that happened there. So not everything that you're going to get from a public trace is going to be totally usable for what you're looking at with traffic. But what it could be useful for is when you have detours and you have road closures, are people following them, or are they making their own detour? You know, so that's kind of the question now. And what I've really found the use for is this, is, you know, so I found some interesting data sources, and I will say, so I did skip a lot of the ride sharing stuff because I wasn't finding that, and particularly where we are in Blaine, you know, ride sharing isn't going to, it doesn't make up the bulk of like our traffic and travel. It's just, you know, people that are driving their own cars. But kind of poking around in some new tools and stuff with OpenStreetMap. And then the biggest takeaway here was finding those other uses. Like I said, you know, monitoring these detour routes that we post for construction and having communication with my engineering department about like, hey, you know, it looks like everyone's using your detour, or, you know, everybody found a different detour. So do we need to like put better signs up, or is there something else we can do to change driver habits here? Analyzing those traffic issues against accident reports. So getting a little validation for my CAD reports has been good to find out that the data that's getting reported from both sources, they actually can validate each other, like, yep, this is where it was located, this is the incident. And then also just having some better visuals when talking to the council member or my city manager to say, hey, so, when we talk about how Google Maps sends everybody down that street, like, let's take a look at some of these traffic maps here. Which actually the historical traffic information from Esri has been a nice visual to use for that. Like I said, I was trying to find some documentation, so maybe somebody knows where the documentation is on this, of what the time period is for that historical data and kind of a little bit more about that. So at this point, time's up, but if anyone wants to ask questions, I can stick around. If anybody wants to be unmuted, raise your hand.
Thank you for your presentations.
You're welcome. Hopefully people learned something. You're welcome, Bill. Good question, Nancy. So Google having the traffic at different times of day with the sliders. Yeah, I've poked around in that a little bit. So this is where some of my capability, where I probably should talk to someone like Kray on some of these things, about utilizing some more of these APIs to get a little more detail out of it. I've been kind of monkeying around with it in QGIS, OpenStreetMap, and that sort of thing. So, but yeah, I've seen that, kind of that predictive traffic where you can say, hey, what's my traffic going to look like at this time of day, or that sort of thing. And that's even in the live traffic, the quote unquote live traffic view on Google, is you can pick like what would the traffic be. So yeah, it probably is a cost. For sure, if it's with Google, there's a cost. And I know that they're going to listen to this recording and they'll probably take away my privileges. There used to be some really great open projects out there. There was one MapZen and some others, but for some reason, I don't know why, but they just kind of like fell off the face of the earth, which is a shame because they were doing a really nice job of harvesting both the rideshare applications and kind of these public, the public tracks like OpenStreetMap is doing. They just had a little bit of everything in there, which was cool. They had a map that they called, a demo map that they called Tron. So for anybody that is familiar with the old Tron, it really did look like that, where they set it up on a dark map background, and they just had all the little lines zooming up and down all over the place. So it was a cool demo, but I really wish that project had stuck around. I'm not sure why it died off. All right, I'm hitting stop recording. Unless you want to hit that, Annika.
Yeah, I can do that.
We're kind of moving into that happy hour time, so